The next type of queue is a priority queue. Priority queue is a data structure in which each element has a priority associated with it, because the priority of the element only will be used to determine the order in which the elements will be processed. So, here in a priority queue, an element with a higher priority is served before an element with the lower priority. Suppose if two elements are having the same priority, means they are served according to their order in the queue. So, these two are the rule of processing the elements of the priority queue. So, if always the element with a higher priority would be processed first before the elements with the lower priority, and two elements are having the same priority, means they are processed based on first come first served basis. When it comes to the implementation of a priority queue, before I discuss about the implementation, let me tell you what is the extra thing we are supposed to give along with the data element, that is priority. If you check, suppose if you want to implement the priority queue using the linked list data structure, normally in a regular linked list, if you take any node will have only two fields, one is to store the data element and another one is to store the address of the next field. But when it comes to the data field, you can have as many data fields you want, it depends upon the applications. If you want to have multiple data fields also you can have, but there must be a data field, but it can have any number of data fields in a node. And when it comes to address field, there must be only one. So, here since it is a priority queue, each and every element must be passed into the node along with its priority only, right. So, when it comes to the data field, two data fields I am going to define in each node here in a priority queue. One is to store the data and another one is to store the priority of the data element, and the other field is to store the address of the next field. So, totally there are three fields. Out of three, two fields are data fields, in which one field I am using it to store the actual data element and another one to store the priority, and the last field is the next field, which would hold the address of the next node. There are, when it comes to the priority queue, there are two ways to implement a priority queue. We can either use a sorted list to store the elements, so that when an element has to be taken out, the queue will not have to be searched for an element with the highest priority, or also we can use the unsorted list also, so that the insertions are always done at the end of the list. So, when it comes to the sorted list, both has advantages as well as the drawbacks. When it comes to sorted list, suppose if you want to sort the list based on its priority, means for insertion it is going to take big O of n time complexity, and for deletion it is going to take big O of 1 time complexity if the list is already sorted based on its priority. Suppose if you don't want to sort the list, in such case for insertion it is going to take a big O of 1 time complexity, because since it is not sorted, you can perform insertions anywhere, right. Like directly you can perform insertion at the end. Only if it is sorted, you have to find out the right position and insert it. So, it is taking n time complexity when it comes to insertion. But when it comes to deletion, since it is already sorted, you can go directly fetch delete the first element. But if the list is not sorted, you can insert it in any order. So, directly you can place insertion at the end. So, it would take only 1 time complexity. But when it comes to deletion, it is going to take big O of n time complexity. Why? Because based on the priority only we will be able to access the data element. So, when it comes to deletion, only the data element which has the topmost priority should be deleted. So, since it is not sorted, you are supposed to find the data element. You have to perform a searching operation to find the data element which is having the high priority, and then only you can delete it. So, it takes big O of n time complexity for deletion. So, both has positive as well as negatives. So, we can prefer any method, like either if you want to sort it, you can perform sorting and you can do whatever the operations you want to do. Otherwise, if you don't want to sort it, yes, you can proceed it, but this is what the time complexity which it is going to take. And when it comes to the representation of priority queue, the priority queue can be represented using arrays or linked list. You can use either array or linked list to implement this priority queue. But when a priority queue is implemented using a linked list, every node of the list will have three parts. One is the data part, this is data part, and the second one is the priority part, where the priority number of the element would be stored, and third one is the address part, which would have the address of the next field. So, totally it would be having three. And when it comes to the characteristics, there are three key characteristics of priority queue. One is priority based processing, because here the elements are processed based on their priority rather than their order of arrival. And the second characteristic is dynamic nature. The priority queue can dynamically adjust the order of elements as new elements are added. And the third characteristic here is heap implementation. This priority queue is commonly implemented using binary heaps. It can be either the min heap or max heap, but other data structures like balanced binary search trees, Fibonacci heaps also, etc., or like this, like other structures also can also be used, can also be implemented using this priority queue. Now let us take one example and see how insertions can be performed here in the priority queue. Let us write the pseudocode for performing insertion. Let me make one example structure, the priority queue structure. Each node must have 3 fields: data field, priority field, and and the head address field. And address of each node is AA, BB, CC and DD, and always first node's address must be stored under a separate variable, because since it does not have any previous node to it. So I am going to create one new variable which is called start, in which I am going to store the address of the first node, and the data element is for the first node is P, and second data element is Q, third data element is R, and fourth data element is S. And the priority is going to be, here it is number 1 and number 3, number 3 again, or okay, number 3 again, and number 5. This is the priority. And addresses, next node address is BB, here CC and DD. Since it is the last element, here it is null. Let's write the pseudocode. Now the pseudocode for performing insertion operation in a priority queue, along with the data element, we are supposed to define, mention the priority also. For example, I want to insert a new value which is which can be X. I want to insert a new value, and the priority of it is going to be 4. Priority of this data element is, the very first step is, since I am using a linked list structure, the very first step is we are supposed to create a new node. I am going to create a new node here with the 3 fields: data field, the priority field and the next field. The node has been created. Let us imagine that the address of new node is new node itself. Let us start writing the pseudocode. Since we know what exactly should be the value we want to insert and also the priority of the value, I think this can be directly written. The new node's address itself is new node, so I can write like this, right? In the place of new node's data field, I can write the value which I want to insert. After executing this statement, in the place of new node's data field, the actual data will be written. And the priority also has been defined explicitly here. In the place of new node's priority field, priority also has been specified here, which is 4. Right, priority has been stored under the variable pri, which is 4. This also can be written. Now the thing is, we are supposed to insert this new node in a right position based on the priority, because here the list has been sorted based on its priority. I am maintaining the sorted list here. When it comes to sorted list, the deletion becomes easy, which is going to take big O of 1 time complexity, and insertion is going to take big O of n time complexity, because since it is already sorted, I am supposed to find the right position based on my priority to insert it in the linked list chain. So these 2 places I have filled. This place I am supposed to fill, and also I have to check along with which node this node can be connected. I am supposed to check without violating the constraint of priority queue, right? Now the thing is, I am supposed to find out the right place where exactly this can be inserted based on the priority. Here the priority given here is 4, which means without breaking the chain, I am supposed to insert it in the right position. Since the priority is 4, either it has to come before 3 or 2 or 1, or sorry, it has to appear after 1, 2, 3, or it has to appear before the number which is greater than 4. It can be 5 or 6 or 8, it should appear before, because we are not following the correct, like after mentioning the priority 1, the priority 2 is missing here. So always all the priorities will not be mentioned. So it can be in any number, but it will not follow the contiguous number here. Just it would follow the sequence. It can be 1, after 1 it can be 5 also, it not necessarily should be 2, or after 2 it should be 3, not like that. After 1 it can be 3 also, after 3 again one more 3 is there. So if you want to insert one more element with the same priority 3, it must appear based on first come first serve. Since there are already 2 elements, data elements are there with the priority 3, if you want to insert one more data element with the priority 3, means it should appear here only, because it is purely based on first come first serve basis, right? So it should appear here only. And so like it should follow the sequence, it should ensure that all the priority, the elements are arranged in the ascending order of the priority. So since it is 4, you have to find out the right place. To find the right place, the condition is going to be, you have to check if start equals to null, because if this is the very first element, directly you can go and insert it, right? If start is equals to null, or check the priority, means the current data element's priority is lesser than start priority. You have to check, this is the condition. So if start is equals to null, which means this is going to be the very first element. Otherwise, if the priority is lesser than start's priority, which means the priority is lesser, for example the start element's priority is 2, and the data element which you want to insert, that element's priority is going to be 1. If so, it's very simple, right? You can perform insertion at the beginning itself. So simply you can write like pointer next equals to, not pointer, sorry, simply you can write like in the place of new nodes next, what should come? In the place of new nodes next, for example I want to insert new data element which is y, and the priority is you just imagine that first node's priority is 2. First node's priority is 2. I want to insert one new data element with the priority 1. In such case, this condition would get satisfied. If you check start is equals to null, no, start is not equals to null. Or the second condition is if priority is lesser than start priority. My current priority is what? PRI. My current priority is 1. Imagine that my current priority is 1. So my current priority is 1. Start priority is what? Start's priority field, if you check, it is 2 has been mentioned. Yes, 1 is lesser than 2, which means the correct place to insert my new node is the first position only. Simply you can write like new node equals to, sorry, simply you can fill the new nodes next field. In the place of new nodes next field, what should come? Start should come, because since the correct position is the first place, it should act as a first node. Simply in the place of new nodes next, I can write the address of what? Start AA. After writing AA, these two would be connected. So the chain has been enabled. Now this is acting as a first node, new node is acting as the first node. So the next step is you are supposed to change the start as the address of new node. So if I write here, after executing this statement, start would get updated to new node. Since the address of new node has been written here, these two would be disconnected, and since it has the address of new node, start address would be pointing the new node only. Now if you check, the chain has been enabled, right? So if the node which you want to insert is going to be the very first node, this condition would be satisfied. Or if the current node's priority is lesser than starting node's priority, means what? We are supposed to place it at the beginning only. The new node is going to act as a first node only. So to fill the new node's next field, simply you can fetch whatever the address has been specified under the start and fill it. And after filling the next field of the new node, you can change the address of the start node. Why? Because the new node is going to act as the very first node. So according to the constraint of the linked list, always the start node should hold the address of the very first node. The very first node is new node, so it is holding the address of new node. Fine. Suppose it is not lesser, it is violating the condition. Take this example. already we have given, right? I just want to insert a new node, new data element x with a priority 4. This is the node and this is the new node. In such case, we are supposed to go to the else part. Go to the else part. You are going to use one pointer because you are supposed to find the right position, because this condition is not satisfied, right? The node which you want to insert is not going to act as a new node anymore because the priority is completely different. So, somewhere in the middle it should fall. So, since you want to find the right position, you are supposed to use one variable, one pointer variable to traverse each node. So, I am going to introduce a pointer, one new variable which is called a pointer, and that pointer should initially point to the start node. So, here the start node is a new node or some other address I will specify here to avoid confusion. This is the structure, and address of the first node is RR, okay, RR. Now, I am using pointer. That pointer is initially pointing the start is RR. If so, the pointer is pointing RR. Pointer is equals to start, and the condition is to find the right position while until the pointers next is not equals to null, because till the last node it has to traverse, right? So, while pointers next is not equals to null, and also pointer next priority is lesser than or equals to new node's priority. This is the condition. While it has to traverse till the last node, otherwise the pointer's next priority is coming lesser than my current new node's priority, it has to traverse. If the condition until it is violating the condition, so if not, the next statement is going to be pointer equals to pointer next. Now check for the condition. Pointer is pointing start, right? Pointer is pointing the start node. The condition is check whether pointers next is not equal to null. Yes, if I check my pointers next is AA, it is not equal to null only. And one more condition is pointers next priority. Pointers next priority is lesser than or equals to priority. Check pointers next priority is lesser only. In such case, sorry, it not lesser because my current priority is 4, it is not lesser. So, it has to traverse. We keep on traversing it until pointer is equal to pointers next. Finally, when the pointers finally, like if you keep traversing it, here also it violates the condition, keep incrementing it, again pointer equal to pointer next, it will go to BB, again it is violating both of this condition, increment the pointer equal to pointers next, here also it would violate. And now when it reaches here, pointers next is lesser than or equals to priority, no. If you check here, when it is here, check pointers next is not equal to null, yes, pointers next is not equal to null. The next condition is pointers next priority. Pointers next is what? Now the pointer is pointing CC, pointers next is what? DD, which means it is pointing the node DD, pointers next is DD, DD's priority you are supposed to check. DD's priority is what? Pointers next is DD, DD's priority is 5, yes, DD's priority is 5, and the current node's priority is, the current new node's priority is 4. Whether it is lesser, the current next is priority, until it is lesser you can proceed lesser or equal to, but it is not lesser, which means we are supposed to stop it, we have to come out of the loop. After coming out of the loop, you are supposed to write, you can start filling the new node, which means we found the right position. Only if it is lesser you can increment to the pointer. If it is not lesser, we can start exchanging the addresses. Now we are supposed to fill this place, right? New node's next field is supposed to be filled. Only if you find the right position, this field can be filled. This next node field can be, can be filled. So in the place of new node's address, since we found the location, in the place of new node's next field, what can be written? The pointers next can be written, right? We found the right place, so which means what? It should fall in between the node CC and the node DD. So in the new node's next field, since I want to insert it here, in the place of new node's next field, the address DD should come. Where the address DD has been placed, in the place of pointers next field, the address DD has been placed. So shall we write like this? In the place of new node's next field, write pointers next. Pointers next is what? DD. So the address DD can be written here in the place of pointers next field. Since the address DD has been written here, these two would be connected, right? Now from where this new node should get connected to, we need to identify. So when the new node and CC would be connected, when you change the address of this field to new node, these two would be connected, right? So if you want to enable a connection between CC and new node, means CC's next field needs to be changed. CC is pointed by the variable called the pointer, so we can write in the place of pointers next, what should come if you want to enable a connection between CC and new node? New node's address should come, so we can write like this: pointers next equals to new node. Now in the place of pointers next, if you write the address of new node, since the new node address has been written, the connection between these two would be disabled, and these two would be connected, right? Now if you check, yes, the connection has been enabled, the proper connection has been enabled, and if you check, all the places has been properly filled also, and check whether based on the priority the list has been ordered or not. Yes, it has been ordered. If you check, the first node's priority is 1, second node's priority is 2, third node's priority is 3, and fourth node's priority is also 3, and the next node priority is 4, and then 5. Yes, it follows the order. The priority as the node has been arranged in ascending order based on its priority. The connection has been enabled. You can come out of the loop, end while, and you can end the pseudocode completely here, right? If so, suppose till the end, if you are not able to find out the right place, which means the last place is the appropriate place, in such case you will get this: the pointer would reach, the start would reach null, the pointer would reach null, pointers next is not equal to null, only you can proceed, right? So when you reach null, this would fail. So any one condition, if it fails also, it has to come out, and you are supposed to interchange the places. End while is here. Both the condition must get satisfied. So in such scenario, in this scenario, this condition was satisfied and this condition didn't get satisfied. And here if you check, like suppose if the current node's priority is 6, the last node is 6 or 8, you just imagine it is 8, which means the last place is going to be the appropriate place to insert a new node, right? In such case, this would get satisfied, like this would fail, like pointers next is not equal to null, only you can proceed. The pointer next would become null, which means you cannot proceed. Simply any one fails also, you can come out of the loop, you can follow this. These two statement would work even to perform insertion at the end also. This is how we are supposed to perform insertion in a priority queue. So based on a priority only, we are supposed to find the right position to insert a new node. Thank you.